Fire changed the world. Those first flames played a transformative role for mankind. A second transformative event occurred in 1895 when Wilhelm Röntgen produced and detected a novel electromagnetic radiation that would be known as Röntgen rays or X-rays. Almost immediately, X-ray mania took off. Within months, systems were being devised to use X-rays for diagnosis of disease, and within 3 years, radiation was being used to treat cancer. Technology and radiation dosimetry were primitive by today's standards, but this early wave of innovation paved the way for the power of radiation to be harnessed for medical imaging and cancer therapy, saving the lives of countless patients. In 1939, the U.S. Army Corps of Engineers began work on the Manhattan Project to produce the world's first atomic weapon. On August 6, 1945, radiation science went from a curiosity to front-page news when the first atomic bomb was deployed. It was that very moment when the world understood the powerful effects of radiation from atomic energy. With that event came a greater need to study and understand radiation and its effects, and how it could be used for peaceful purposes. The Radiation Research Society was founded by a group of dedicated scientists and physician scientists who understood that radiation was a tool that could be used for the advancement of mankind. The radiation research community wanted the study of radiation to be steered by hope, not driven by fear. The multiple disciplines of the radiation sciences have advanced well beyond what the early giants of the field could have imagined. These are a few accounts of the legends who forged the path for future generations to come. Jack Fowler had long been intrigued and inspired by the extraordinary power and utility of radiation. With his brilliant mind and tireless energy, Jack was instrumental in helping to shape the foundations of the Radiation Research Society in its early years.
I joined the Gray Laboratory in 1985 while Jack was director, and he very quickly became a close friend and colleague, as was the nature of him, even being director within the centre, myself being a relatively new junior postdoctoral researcher at that time. He very quickly struck up relationships with everybody who came into contact with him. Jack was one of the most enthusiastic individuals I've ever met in my career. He had a great ability to really excite anybody who stopped to talk to him about science and the application of radiation biology. And he mentored many individuals through his career. His interests were varied. He's most well known for the application of the linear quadratic model in terms of taking the approach of mathematically simulating fractionation of clinical treatments. He was an exceptional scientist, and he was an exceptional mentor as well. He really enthused everybody who came into contact with him, and that enthusiasm you could see with the way that people then went about their work and their experiments after having even the shortest discussion with him. What we do nowadays in terms of how we apply fractionated radiotherapy in a clinical setting, a lot of the fundamental basis for that was laid out by a lot of Jack's seminal work.
In the 1970s and 80s, Julie DENEKAMP gained international recognition for her novel research. She approached her work with integrity and rigor to achieve a level of quality worthy of such recognition.
I first met Julie in 1979 when I was an assistant professor at the University of Arizona. She was one of the very first people to talk about the idea of targeting tumor vasculature as a way to cure cancer. And that was really very novel at the time. But basically, she was saying, if you kill one endothelial cell, which is a cell that lines a blood vessel, that's going to stop that blood vessel from having flow, and you would kill 10,000 tumor cells. You think about it, that was really quite profound, and I think it increased people's awareness of the importance of the vasculature in terms of the survival of cancer. But I think the other thing about Julie was that she was a person who demanded excellence of everybody. When she came to the University of Arizona as a visiting professor, and I had been there for a year or two, and I had started working on this model called the skin-fold window chamber, which was very new at the time. And so I sat down with her and showed her the model and what we were doing with it. And I spent 5 or 10 minutes describing it. And then she spent the next hour and a half with me poking holes in it. What about this? What about that? You thought about this? Have you thought about that? And I just, after it was over, I thought, geez, am I in the wrong business? I felt completely overwhelmed. But in fact, what it did was it woke me up. Anything you're doing, you have to be critical of it, self-critical. I think one of the things that she exemplified is a scientist of the highest integrity. Everything she did, there's a bit of love behind it, because she really cared about what they were doing. That came across to all the members of the society.
Scientific research is a constantly evolving field, which brings about new discoveries as well as opportunities to advance radiation treatment. The Radiation Research Society had the privilege and good fortune to count Herman Suit as one of its members. He was instrumental in the development of many new innovations in the field of radiation oncology. Michael Goteen once referred to him as a giant of modern medical physics, summing up Herman's impact on one of the pillars of the radiation sciences.
I think it would be hard to overstate Herman's contributions to our field, and that ranges from both his contributions in the clinic as well as his contributions to radiation biology. Herman Suit was the professor of radiation oncology at Massachusetts General Hospital, and he was the head of the department there since the early 1980s. He was a pioneer in the treatment of sarcomas. He really pioneered limb salvage treatment for sarcomas, combining conservative surgery and radiation therapy with high rates of tumor control and excellent functional outcome. He was also a pioneer in the use of protons. He collaborated with Michael Goteen to develop the first major proton treatment program in the United States. But as well, his contributions in radiation biology are really legend. Herman's other contribution was his focus when treating patients on trying to do the absolute best treatment for every patient he saw. He really felt that there shouldn't be any limits on the kind of technology we should try to bring to bear on a patient to improve their outcome. He really focused on curing the patient with cancer, minimizing the side effects of treatment, and engaging every possible technology and bit of biologic information we would have to try to improve the outcome for every patient we treated.
Susan Wallace was a pioneer among women working in scientific research. She played an important role in the genetic revolution, and her work in DNA repair was groundbreaking. Susan became the first woman to serve as president of the Radiation Research Society.
Oh, she was a mentor and a role model. When I first moved to Mass General Hospital, my first faculty position there, with Ed Epp, who at that time was a past president of Radiation Research Society. He was my new boss there. And one of the first things he said to me was that I really needed to have good mentors and good female role models, and one of the best I could find was Susan Wallace. He was such a fan of hers. She was for 30 years chair of the Department of Molecular Biology and Microbiology at the University of Vermont in Burlington. She had many, many students and postdocs there that she trained. She was the first woman president of the Radiation Research Society. She was the Radiation Research Society FOWLER lecturer, and she gave a memorable lecture. Everybody remembers it because she talked about DNA repair, and she put it in terms of baseball. And the title was Who's on First? And she talked about the different repair enzymes and how they came in sequentially one after the other to repair DNA damage. She still has a fine legacy of students and postdocs who have carried on her work, people still from the University of Vermont who are now there that are continuing her legacy and research. She also was very active in founding the women's group within the Radiation Research Society some 30+ years ago.
Chris Potten was an influential figure in the field of epithelial stem cell biology, having made several seminal contributions in this area throughout his career. He was well respected and admired by his many students and colleagues. Radiation Research Society members found great value in Chris's intellect, original thinking, curiosity, and kindness.
I knew Chris probably for getting on for 30 years. I first went into Chris's lab as an undergrad intern and went back to do a postdoc, and then the two of us set up Epistem together. I think the main legacy is really the depth of research in intestinal stem cell biology. Chris was one of the pioneers of stem cell research, epithelial stem cell research, and particularly in relation to RRS, the radiological response of the stem cells, the clonogenic cells. He really, in the 60s and 70s, moved that path along, particularly the intestinal biology and skin biology. I guess you could say he was one of the kind of true gentlemen of science, with a big thing about encouraging the next generation. Very keen on encouraging new stem cell biologists. There's several stem cell biology labs around the world that the leaders did their PhDs in Chris's lab. Taking aside the science, he was somebody who treated everybody equally, whether you were the janitor or the chief executive of the company. He really had time for everybody, always talked to everybody. Apart from being very astute and a really good biologist and an all-round good guy, he was also had quite a wicked sense of humour. And a lot of people here will recognise that.
The contributions of these revolutionary scientists, as well as the example of their determination and principles, continue to inspire today. In this spirit, the Radiation Society membership continues to move towards a brighter and sustainable future. This is evident when we gather annually, whether in discussion around a poster or a seminal concept introduced in a lecture, but mostly in our camaraderie as we each carry the torch of our continuing legacy.